All right.
Hello, everybody. My name is Michael,
Oh
and I
my
am a student of
gosh.
you.
Get out of here. Let's see what's going on here. All right. Welcome, everybody. How's everybody doing? Welcome back. Where are you, my live stream? Where are you, live stream? Where are you? There you are. Oh, notebook instead of. There you go. Well, there goes the notebook. Alright, let's get this loaded up. I'm tired today. Alright, cool. Hello, everybody. Welcome back to the stream so far. Welcome today. I appreciate you joining me again for the study session. Today is Monday, April 21st, 2025. Another Monday down, another Monday in. Here we go, guys. We are here doing our thing. I appreciate you guys for joining me so far, and welcome to the stream. All right. What do we want to warm up with today? I want to work on the project, but I like coding projects. Let's keep coding projects. All right. So we're back on the project here of our current iteration of the thin layer chromatography simulation. This is our simulation here. We are going to try and get this, implement a few features here. We'll wait for some people to get in here though. We'll get some music going. I need some music. I need something going here. I'm struggling to stay awake. Let me drink some water. The straw of my thing fell off. Get back on there. Get back on there. Ah, there we go. Zanab, welcome, my friend. How are you? Welcome back. Drink some water. Hopefully that kind of wakes us up a little bit more. All right, here we go. I'm just tired after work, you guys. Sitting in traffic lulls me to sleep. All right. Hey, Zane, how's it going? Welcome in. Appreciate you for joining me once again. How's it going? If anybody's on Twitch, let me know if you're out there. Hello, everybody. All right, so this is our current iteration of the chromatography project. We have built this yesterday. This is what we have so far. Is we have basically, we have a whole total of 150 frames of eligible growth that we're going to compute. Um, so that's the interesting part here. Okay, so let's go ahead and see. Let's go over our code here. So I was starting to write yesterday this class for the overall for our compound. I started to write this last night. So let's go get status. We're in our compound classes branch. Good. And modify plots.py. Hey Prism, how's it going? Welcome in. Welcome in, you guys. If you're part of the early crew, smash that like. Thank you guys so much for being here. Welcome, welcome. We're almost to 1800. Like I said, is I think we're gonna do CS2 case opening every like 50 subs or something, and like just one case for every 50 subs, and then we'll give away that item. We'll just trade it to whoever on Steam. Whoever is currently in the stream, we'll do a poll and give it away. So thank you guys so much for being here. All right. Compound here. Okay, let's get some music going though. I want to get some tunes going here. Bum, bum, bum. I'm gonna try to play this and let's see if I get copywritten. I think I'll be okay just because I really I commented and someone liked it and everything, so I wonder. Let's see if we'll get hit here. I'm not sure. Yeah, if I get like a 2 mil AK, we might have to split the gain on that one. Right? If we get something real crazy, we'll have to see what we do. Like that's just that's crazy. I mean, I'm down to give it away to you guys for being here. That's just the luck of the draw, right? But well, maybe we could work out something to where we could like, you know, we could split if we get something crazy over a certain limit. I don't know. Do we trade in like half the value and then get half the value in cases to re-roll back on the stream? Like it's to keep going. I don't know. That's great. That'd be interesting though. Hey Muna, how's it going? Yeah, so the chromatography project, this is it right now. If you've ever done thin layer chromatography, this is it right here. So this is just simulating what's happening in the lab. You have a piece of paper or some sort of medium, which is this plane, and then you have various compounds that you start at a certain position on the x-axis, and then you take the piece of paper and you dip the bottom of it below the x-axis here into some sort of solvent, and that solvent will begin to climb and soak through the medium. So this black represents the perfect one-to-one solvent travel, right? This is how the solvent is traveling up, and then these are the RF. These travel at a various factor of that called the RF factor, the R factor, whatever RF retention factor, and so then these are being retained by the plane by a certain degree in relation to the solvent. So usually in the form of polarity, right? So if the medium, the piece of paper is a positively polarized plane, and other positively polarized molecules are traveling along with this solvent as it soaks up, this blue would have a highly positive charge because it would be attracted to this plane and it's moving forward, whereas um, I believe that's the case, whereas nonpolar ones would not move as much because the plane, there's repulsion going on in the plane. It doesn't travel very easily through this plane. Sometimes I get those inverse, but I think that's right. Okay, so I started writing this class yesterday in order to, manipulate some of these things a little bit better to make this maybe a little bit more object oriented. So, right, every compound has a name, an x coordinate, a y coordinate, and a retention factor. I was using doc strings, you guys. Hey, Harion X88 on Twitch. Thanks for the comment. Welcome in, dude. Appreciate you for jumping in here. My name is Michael. For those that are new, got a degree in human bio and chemistry, and been teaching myself how to code for about 10 months now after my 9 to 5 job as a chemist. Right, Muna? Isn't that cool? Doesn't that kind of resemble that same methodology? It's kind of cool to see it like you can predict, based on you can mess around with the RF value. So my goal is to make this kind of like a web app for people to mess around with for educational purposes, hopefully. So, and what I think I might do is I might solicit you guys to help me out to build the front end because I like building the back end stuff and the science stuff. I don't really, the front end stuff is like, whatever. I don't, I'll build it, but it's not really my cup of tea. But it's okay. So I might need to solicit you guys, and we'll open source this to the community here, and we'll sign out some front end people to build out the front end. That'd be cool. What do you guys think? Okay, so thanks, Orion. Or is it Orion? Orion X88? Okay, so they have a retention factor, a name, an X corner, Y corner. So then the update function, right? They have an update function where you update data, returns none, just updates the current data of the X coordinate, Y coordinate. And then we have an optional retention factor. If retention factor, right? If not is instance, um, then raises value or we'll put this nested in the if retention factor, and then that's it. This is gonna return right. So if not retention factor given, they don't have to give a retention factor to update a new coordinate or update data, but they can update these individually. I mean, we could give an individual function to update chords and just have do X and Y coordinates only, but that's whatever. I mean, we have so then I wrote this function here, this get all, which will just return a list comprehension of all the values from the object dictionary itself. And then I have for get data, which will return all of the information except for the name. Um, so then let's say let's do one for uh, def get chords on self, right? Which will return back a list object. We're going to return in this, we're going to return back two lists, right? Self dot xchord, and we're going to return back another list self dot ychord. So that'll return back the chords individually within a list encapsulation, so per matplotlib. Okay, so that'll get chords. So this, let's try a little doc string here. Get all information related to a compound returned in a list. Okay, and then in this one we're going to say we're going to get all integer float data related to a compound returned in a list compound dot retention factor is optional. No, that's on this up here. Okay, so now what we'll do is for on get coordinates, we're going to say get x chord and y chord, each within its own list, remains compatible with blah, blah. Okay, nice. So then on update, it returns none. Compound dot new retention factor is optional. Optional update param. Okay, any other functions we should add here, you guys? The title says Project Mikey. What? Someone's in my eye. Oh, something is in my eye. I had some Takis and I think I touched my eye with the dust. Oh, you guys probably can't hear the tunes. There you go. Oh, stream title. No. Major L. Just do a pull request to, and fix it for me. No, embarrassing. Manage videos. Live. Edit. Project. Save. Alright, there we go. GGI, yeah, right? It's like, God, it's gonna be over. Okay, so okay, so that's cool. Now in our plots, we're giving colors. We're enumerating our current list of compounds. We're choosing a color through this rotating scale. Any other methods you guys think we should add? Source rather than app? Okay, what do you name that? Okay, source. Okay. Okay, so now we have so now our goal is going to be to basically create compounds in our dictionary right? By creating objects here that we can manipulate individually. So this is what we're gonna do, is we have classes here. Let's go. So we're in plots, which is outside of classes. So from classes, import from classes dot compound, import the compound object. So this is going to be objects, custom objects. This is going to be matplotlib objects, and custom objects. Okay, so now we have, let me go ahead and say on this, let's say git add on this current branch, git commit. Let's just stay organized here and say that we framed we framed the compound class. Okay, and then yeah. So now we're going to get, so we committed those. I'm going to git push that. So now we go git status here. We're on our branching origin compound classes, right? Okay. Hey Guppy, welcome, dude. Welcome back on the Twitch, my friend. I just went off for half the last stream and already lost track of the project, bro. Where'd all this come from? We got stuff up running quick here, Don Soap. The Matplotlib's pretty easy to use. I've been really watching some videos on it, and it's going quite quick. And then I stayed up for about another 2 hours off stream in the Discord last night and hung out in the voice chat. Only Mahan stopped in and said what's up. But I hung out in there and I wrote this class here last night in those like 2 hours, hour and a half just hanging out. I was tired though. I was like nodding off. Okay, so we're gonna take our class here and we're gonna get it functional with this here. So we have compounds here. Let's go ahead and say, make a new thing. Like let's just say temp compound objects, right? And we're gonna have comp1 is equal to compound. We'll keep standard. Comp1 is equal to compound. We'll give it, right, it needs a name, which will be solvent. And then we'll give it all these parameters. So the initial x coordinate will be a 1. So I guess let's do this. Let's say for in range, let's generate, we want to generate 6 of these. If I equals to 0, we're going to create a how can I create compounds on the fly? So let's just create a dictionary comprehension then. Let's say, so the key is going to be comp dot name. The value will be the compound or the comp, right, itself for compound in range of 6 . How do I create the compound object here? Walrus? No. How do I... Do they follow the structure of the dict there? Yeah, that's what we're trying to get here. Okay, so we're trying to create some objects here, right? Compound objects. So we want to assign the compound name and the compound itself as the compound dot so we want to get data, which will return me the value of x, y, and retention factor in a list itself. For comp name, how can I create this object, assigning it to comp, doing it 6 times, and then creating these dictionary references at the same time? Yeah, Dawn soap, exactly. Which is basically just like a percentage of how fast it goes up in relation to the solvent. That's all it is. It's pretty easy once you can understand it. So 90% as fast as the solvent, or 33% as fast as the solvent. So we'll say was the name and data already assigned? Yeah, I created it here. We want to create a compound. Okay, so we're gonna have to do this. We're gonna go create a compound we're going to have to do a list comprehension at first and then a dictionary comprehension out of that. So compound for comp. I have to give it y value, x values. So let's go here. Let's say for I in range of 6, we want to generate a compound where the name object is equal to comp I so the name is comp I, and we want to then say the x coordinate is going to be I, and then the y coordinate is going to be 0, and then the retention factor is going to be a random num, right? So that's what we'll need to generate there. Okay. We're going to create 6 compounds, and we're going to, I guess, create them. List here up, right? And then we're going to append the compound here, right? So we're going to generate the compounds, append them to this list, and then we want to get this data here. Right, because we're calling this generate data, which is returning back a list of quantity for each x, so 10 points of x and 10 points of y, where y increases each time by the retention factor. Yeah, that's what I was going to do, is use NumPy to get the random. Okay, so then temp compounds. Did you buy more Amazon, Mike? I'm running out of money, boys. Help! No, I'm buying every day. I got my auto buys on. And when people get scared like this, I just set my auto buys on. I close the app. There's no point in watching this stuff and getting anxious, watching it go down. It's gonna come back up eventually, as the stock market does. So just set your auto buys and walk away. Don't be trading during this time. It's not worth it. We're gonna start CS case gambling, right? That's gonna be our new thing. Yeah, I haven't been playing anything. I don't play puts. I like to follow momentum, and momentum is heaviest when, or not, I guess it's heaviest when it's going down, right? Because it just washes people. But more like momentum is most seen, going up. It's the odds are, stocks go up over time. So I like to, play against that, play alongside that hedge, or that edge, and and I like to support companies when they're doing well and whatnot. What should I buy after the dip, since we'll go up in 27, 28? Dude, honestly, I think that companies like you said, like Amazon, I'm waiting for AMD to turn a freaking profit or something, like at least do some positive earnings and outlook here one of these, quarters. I don't know. Their CEO keeps getting like top praises, but they can't produce positive stock numbers for like 2.5 years. But it's just, yeah, it's pretty annoying. But yeah, and then who else? I really think that a really slept on company that you should be buying up right now is Cava, Cava. Now, this is not financial advice, but the growth on that company is, similar trajectory to, I think, like a Chipotle. I personally really, really enjoy and like the product. If you've ever had kava, it's really good. If you don't like kava, you're just picky and you're just picky. You like chicken fingers and pizza every day. um, I know a solid buy. I'm gonna keep buying over and over again on every dip is Costco. Um, it's the only place I go, no matter the time, no matter the event, no matter the economic condition. It is always packed, packed. You can't leave there without spending $100. Um, Same with Apple stores, really too. I mean, I let my eyes kind of do the. I see where the people are. Like, that's how I kind of like to think about it. Okay, so we're gonna create compounds and append each compound to this list here. Okay, we are then going to generate a dictionary. Say, right, we're going to create a dictionary object and say compounds is equal to here, and say we're going to get compound dot name, compound dot get data for compound in compounds list. Now that will say we'll say if I equals to 0, we're going to generate a compounds list, right? We're going to dot append we're going to pretty much do this same thing, but we're going to generate a compound here for solvent, right? And then have the solvent have a retention factor of 1.0. So now we need to generate the temp variable. So rand num, right? So we need to generate a random number between 1 and 0 and 1 on every iteration of this loop. So here we go. So if it's 0, we don't need to generate the random number. And so else, we need to have an else condition here. So on the else condition, we're going to generate a random number equals to numpy dot a rand numpy dot random size, return random float in half open interval. Return floats in a half open interval 0 to 1. So let me print rand number here. Let me comment out this compounds here. And let's see, and then let's print our compounds here. So now let's see what happens. Okay, so I get solvent, comp1. So this is generating pretty large RF value. So we want to lower this range down to just 2 decimal places. And the solvent's on the 0, which is fine, honestly. So then I could reduce this down even further to show the solvent on the 0, which I kind of like. Honestly, my ideal goal would be to simulate, have the solvent be like a gray box across the entire background to mimic like that soaking feature as it creeps up, along this line right here. When I hit 2K, launch meme coin. Hawk to a coin, Mike to a coin, Mike to a coin. What 777? Wow, 1777. That's a cool subscriber count. Who was lucky number 1777? Welcome to you, my friend. What do you guys think? How do you think it looks so far? So these are our random values that are being printed. Yikes, dong soap. Oh, did someone unsub? We're still at 1777. Thank you guys so much for being here. Leave a like if you guys are here. Appreciate you. Hearts in chat for you guys. 1777. You guys are awesome. I gotta download CS2 after this stream because we're probably gonna hit 1800 next time. We gotta open up a case. The thing is though, is I have some cases that are worth like 15 bucks from back in the day when I used to play a lot. So let me tell you guys a fun story though real quick. Is when I was like, I don't know, I think I was a freshman in high school. So 15, 14 going on 15 maybe. I opened up like 4 CSGO cases. My first ever cases ever. And I opened up these 4 cases and I hit a knife on one of these cases. I was freaking out, going crazy. My brother, who was like a little kid, was freaking out, going crazy. So what do you do when you're 15 years old and you just got a knife that's worth 200 bucks? Well, you gamble it. So I threw that thing in the casino and I gambled it. You can see where I got my stock habits from. I gambled it and I leveled that thing up. I traded that up to a Karambit blue steel. So it was a gut knife. What's it called? It's like purple. It has like it looks like, like writing on it, kind of like scribing on it. But that's what the gut knife was. And then I traded that thing up with gambling up to a Karambit blue steel that's worth now like 1,200 bucks, 1,100 bucks. And then we lost it all, boys. 15-year-old Mike learned a valuable lesson that year. Okay, so this is what we got going on right now. Isn't that crazy? Karambit blue steel. Oh, it was so nice. I was like going in my matches with my career. I was like, it was so cool. I was like, oh, it was so fun. All right, this is what we got right now. So we have the solvent being creeping up by a factor of 1 no matter what. So now what I want to do is, now that we have this working appropriately for this, we can delete this, take this, put this. Eventually we won't even need this compounds list. we'll have compounds be generated based off of user input on the front end into this list, and then we will populate them right here, right? So the thing is, though, is now what we can do is I'll go here and I'm going to go get status. So yeah, we have plots changed. So we'll say git add, git commit here. We'll say compound class into integration. Well, integration, we'll say to plots, right? Okay, so now that commits that, and we can git push that up. Git status here. So now we're up to date, nothing commit on our branch off of origin. We're going to now say git checkout dev. So now we're on the dev branch. So what happens if I git checkout origin? Oh, or sorry. Let's git checkout main. So main doesn't really have anything different from what's here. So this is still in the old format. So now if I go git checkout dev, I go clear, now I go git status here, where's fine. Now I go git merge compound classes. That merges compound classes into this. Mondev. So now I have source, I have my classes compound with all my new data, and then my plots with my new classes information on the dev branch. Cool, now I'll do git. We want to push that. Conventional commits. No, I've never heard of such a thing, Mr. Down Soap. So let's look up how to delete old branch that was merged, then push to remote. To delete a local git branch that has already been merged. Git branch, delete the branch name. Local branch, and then delete the remote branch. We go, so we're on dev. Do I do this on checkout main? Okay, so git check out main, git branch dash d compound dash classes. When deleting branch compound has been merged to what was that? Okay. Oh shoot, just deleted it all. Well, there it all went. And then git push origin. So there's nothing to work on here. Plots here. On main. Now if I go git check out dev, and I go to the dev branch, now I have this, my source. Now I go git check out compound cool, so no compound classes. So, but if I go to GitHub and go to my TLC simulator, I have two branches here, main and dev is source. Okay, cool. Yeah, Git stuff is like I really have to like think about it. Like I'm like, where am I in Git in the tree? Like where am I? Like, yeah. 26th of Algebra 2 exam, linear algebra 2. I wish it was just algebra 2. All right, we can study some linear algebra together. We can get into that. Okay. So now what we can do is I want to work on, right, so now we have temp compounds object. And then we have the compounds right here in the dictionary that we're generating. And then we're getting all the x values and y values. Plot object to the list. We're calling ax.plot. Plot objects to the list. Right? Plot objects to the list. Which our goal is we're appending a plot. Into plot objects. A plot. Okay. Okay, so we're creating a list of objects to plot. Right? we're setting limits of the axis here. We set the X limits here. Perfect. And then the Y limits based on the frames. So then when we initialize for object and object plots, we set data to a blank thing and return object plots. When we update, given a frame, we iterate over the compound. Over the compounds list, go into plot objects at that index of our compounds, and we set the data of that individual compound of every point forward, and we return the plot objects. So then we call the animation function on our current figure, which houses our plot objects. We call the update function on frames over this loop, over this range, I'm sorry. And then the initialization on the start is this, where we set them all to nothing. Okay. Hey Jer, welcome. This is the thin layer chromatography simulator. It's currently, if you've ever done this experiment in chemistry class, it basically tracks the ratio of movement between a solvent and a compound against a medium in the background. So you can see that these ones move pretty slow compared to these other ones, because they have attraction to the medium. Okay. So then, I'm getting tired, you guys. I've only been streaming for an hour. What do we want to generate here? What's our next thing we want to do? Okay, so my next thing I want to do is, let's go here, let's go get status. Okay, so we changed the plot a little bit. Where do we change that? We change plots.py by giving it a different length here. So we'll say git add. We'll say git commit. We'll say fix x axis limit. We'll push that up. Now we can clear, and we'll go git checkout -b. We'll check out. We're on right git status. We're on the dev branch, so it's git checkout -b name feature, right? check out dash B. We're going to call this random random we'll say rand movement. Rand move feature. Now, I don't know what to call this. Random element feature. Extra negative one, a Y for negative one. Just to show one more back. Rand element. No, we'll say, what do I want to call this? I want to call this, we'll call this point buffer random. Okay, so now we're on this guy. So let me push this branch. So we got to set upstream to origin, which is this code here. All right. So what I want to do here is when we plot each point, I want to slightly alter. So when we generate data, we currently take its current value. See, its x value never changes, but its y value slightly changes based upon a retention factor, right? So what I want to do is I want to create a randomness element to this placement, but not too random. So random element. And what I mean by that is this isn't going to perfectly go straight up in a line, right? This isn't going to grow, or when this compound spreads across the medium, it's not going to go straight up. It's going to have a little bit of sway. So I want to give it, so x buffer is equal to the numpy.random and give me example of the numpy.random. Generate a single floating point value from 0 to 1.0. You can also generate an array of numbers, 5 floating point values between 1 and 0. You can generate a 2D array. How can I specify the params of the rand num? You want to change the range, say from 0 to 100 for an array. Oh, so high minus low 100 plus like 100 to the random integer between that range. High minus low plus low 100 times. This is better specifying a specific range, uniform. Okay, so dot uniform. Draw samples from uniform distribution. Samples are uniformly distributed over half open interval. So the low on this is going to be so I'm going to say the X buffer low is going to equal to the compound Okay, so the X buffer low that we'll give this is the compound that we're currently working with. Index of 0, which is the current X, which is the X value. We're going to say I want the low to be 1%. So if it's a value of 5, you can get slight variation. It was 10% too much. 50.5 movement on a 5. So 0.5 would move it. That's too much in the maximum. I think 1%, maybe. Let's try 2% and we'll scale back from there. So we'll say the buffer low times 0.2. So if it's, right, if the first value is 1, the low will be 2% of 1, which we don't want to have that. We want it to be 80% of 1, the inverse, right? Yeah, so 0.8. So now it can travel from 0.8 to 1.2 on the high end. So this is, we'll say, we'll give this, so we'll use a variable here rather than hard coding a value. So the buffer, so we'll say buffer factor is equal to 0.8 or like so this is within 20% of original X, right? X point. So then we'll multiply this by just the buffer factor for the X buffer low. I'll be right back, you guys. Let me go get our tissue for that one. Let me refill my drink while I'm at it, my friends. I think we ran out of the tunes ended. Let's go ahead and put on another thing here. Uh-oh, we got an ad.
Now you can turn it into reality with hosting or Horizons. To start,
I'll be right back, you guys. We're grabbing a refill on my drink. My drink! My Diet Dr. Coke! All right, we got our refill. What's your guys' drink of choice? If you guys had like a fountain of it at your home. This is kind of like some soft, like space jazz. All right. So now what we're gonna do is we're generating a buffer low here, which will be a basically a slight skewed that will automatically be applied to this value. So then what we're going to do buffer factor, buffer low, our buffer, our unique buffer value, so our buffer high is equal to our compound index 0 so our buffer factor is going to be 0.2, 20%. So we're going to multiply by 1 minus 0.2. And so that's going to equal to 0.8. And then so if we're on, let's say, the x value of 1, we're going to have a low buffer of 0.8 and a high buffer of this times 1 plus 0.2, or buffer factor. Right, because if we're on value of 1 for x factor, x value, and we times this by 1 plus 1 times 1.2, because it's a 2.4, no. We want to make it just 20% higher. So we need to add it we have to get 20% of the buffer factor. So we have to get the compound times the buffer factor less the current compound, and then plus the current compound, x value. And then this was compound index 0 plus compound. So now this will be, if the compound index 0 is a value of 1 for its the x-axis value, times the 20% gives us 0.2, added on to the 1 gives us 1.2. This will give us 0.2, or 0.2 less, which would be 0.8. Right, so if it's compound 1 is 1 times 0.2 for the buffer factor, 1 minus the buffer factor equals 2.8 for the buffer low. So now we're going to create a high equal to the X buffer high, and then we'll take this value, we're going to insert it into a new generation within this range of quantity, and so I want to slightly modify the X value here by the random value, right? Do I want to add the random value or subtract the random value? Well, I should probably leave that up to chance as well. Can I generate random num that is 1 or 0? NumPy rand int. And then, so on every loop, so this is our buffer element, X buffer. Generating X data, but we're taking our X current value and we need to either add or subtract. So let's generate I don't know, temp is equal to numpy.random.rand int between 0 and 2. We say that rand int here, let's say that if rand int equals to 1, we're going to add. So we're going to say temp equals to compound, or X, we'll say X chord is equal to compound index 0 plus the X buffer. No, we don't want to add it, the buffer. We want to set it equal to the value generated in between that range, the random int in between, or the buffer itself in between the high and the low. So we can remove all this. We don't need a random integer. We can just set our compound is going to be equal to x buffer. Right, so now what will happen is our x value will start to sway horizontally between a buffer range of 20% as it goes up the values here. So if I go and run here, see, it looks like 20% is a little bit too much. I mean, we're getting a lot of spread on these other ones. We're getting like, because as it scales up, 20% is pretty, this one looks okay, but remember, as we can't use a linear factor. Then we need to, our factor has to have a scale to it as well. Right, we need to, because 20% of 5 is, 10%, it's just 50 cents, 20% would be a whole dollar. So that's why you're able to move from 4 to 1 here, 4, right? But, so we need it to kind of mimic this. McDonald's, Coke, Snapple, Inca Cola. I'm not even sure if that was a... Okay. So we don't need to generate data. Okay, so then I need to scale my factor as well. So as compound 0, so this gives me +1. So on the low, I can't just directly do minus the 20%. I need to do minus times the current. So I need to multiply with 1. I am applying some buffer x randomization for the points in my TLC simulator. Not every point in a real TLC plate is perfectly linear in the y direction, in the x direction. x. I am applying a 20% buffer to these x data points, but as the x value increases, the 20% factor becomes too large. How can I divide or by my current x value to reduce the factor by its own factor for scale? You're adding a bit of natural randomness jitter to simulate the TL speeds aren't perfectly aligned, but you don't want the randomness to grow too big as x increases. Nice touch. You're right that using a fixed 20% buffer randomization factor normalize the buffer by x. If you multiply by x and divide by x, you're just canceling things out, but I think you're going for a way to reduce the randomness for larger values that might be helpful. So buffer. So I will give it here what I'm currently doing. And usually I don't like to do this, but I'm learning here. I'll give it my entire generate data function. This is how I am data for these points to populate. Nice, this is a clean structure. You're generating TLC like spot coordinates with jittered x values and evenly spaced y based on column 2, I assume. Right now, though, you're applying the same buffer regardless of how large x becomes, which, as you notice, starts to get wobbly when x becomes too large. So it's dynamically, so the buffer factor would be 0.2 divided by the square root of current x plus 1 times e to the negative 5, or log x plus 1. So we got to put this here. So it wants me to divide by the square root of my current x plus this value here. So the buffer gives you, by the square root of x, avoids division by 0 if x is 0. Oh, interesting. So we can apply a divided by numpy dot square root of compound index 0 for the x value plus a 1e to the negative 5 here, just so it doesn't end up on for a 0 as well. Okay, interesting. So now if we run here, well, look at it, kind of now it's doing some weird stuff. It's kind of cool to see these like models like work, these math, visualizations kind of work out just by randomness. But there is some uniformity going on here that we don't really want. Hey, Zos Media. How's it going? Mike, you gotta try the Inca Cola. That sounds cool. I've been to some of those Inca or like Mayan sites and stuff in Mexico. Okay, so generate data on every compound. So then factor 0.2. So let's give it less factor here. Let's give it a 10% factor. Oh, because it's getting randomization off of that one. Oh, that's interesting. So right now what it's doing is because I'm calling, I'm specifying the compound 0 at every iteration through this, you get a little bit of randomization each time further on. So it randomizes again and again and again, but randomizes on the new randomization rather than the original. So that's why we're generating random, like we kind of have this pattern here where we move off in one direction and then we kind of scale back over because then we follow a certain trend and then we'll kind of break the trend, and because we're randomizing on the random. So until the trend breaks. Okay, so then what we have to do to fix that is we need to apply so start x is equal to compound index 0, and then we'll put start x here. So we generate a random number off of that original value rather than the random value.
With Asana, AI teammates can help level up your goals by connecting them to relevant projects. So every team knows their role in the bigger picture. Asana, the #1 AI work management platform. Try for free today at asana.com.
Oh, then we're resaving the compound as the next one. Okay, so no, hold on. So let's leave it there. And then let's just assign It generated the X data, and then we need to make sure that that stays there, and that'll solve it. So this is appending, we want to append the X buffer here. There we go. Woohoo! We got it. Yes. All right. So now this looks like a real kind of like chromatography simulation, but we got to turn this up now. So let's turn this up to like 350, and then this will really start to blot right here, right? As it's kind of like soaking into the paper kind of and creeping its way up, right? So even this spread might be a little bit too much. Look at that. Look at that. That looks so cool. Nice mullet. I got a mullet. I got hair. Oh boy. I gotta get a haircut. Before I started really starting streaming full time, in terms of full time every day, I had really long hair down to my nips, and I cut it off right before. Well, it's just not traveling as far, Mahan, so it's just, clumping up and creating more density within itself, right? So it's just, it's just a shorter, fatter stack, because more and more, you have more and more chance to fill up that singular plane, that square footage, whereas you're filling up square footage and it just looks, thinner. Woohoo! Look at that. So what we can generate is, every time we do it, it'll be a new random simulation here. Oh, this one is not even moving. No, dude, ARC 2005, bro. I'm fighting it with all my might, dude. Let me tell you, I'm fighting it with all my might. I've been fighting it since I was 18. Let me tell you. And anyone else fighting that MPB? That brutal father time coming for you? Okay, so perfect. Now what happens if now let me go ahead and reduce this. Let me reduce this buffer even further. Okay, so let's reduce this even further. And then let's make these like 200. My junior monster scene. No. If my senior is bald, you're cooked. Yeah, my dad's bald. Let me tell you, bald. Yeah, like the usual arc, minoxidil, finasteride, that kind of stuff. I'm 20, no signs yet, but I might need to start because not trying to go to Turkey in the foreseeable future. Your boy might need that. R.I.P. What shampoo do I use? Honestly, I use like Dollar Tree shampoo. We've lasted this long though. My dad was pretty bald at this point in time, but I have noticed that the past year since I turned 26 so far has been ramping up. I haven't been as stressed. I don't like college was definitely more stressful at a point in my life and stuff, but I it's I definitely noticed like in the sink, in the shower, there's more hair and stuff, but hopefully the products and and what I use and whatnot is helping compensate for the loss. Okay, so then let's lower this randomization factor even further to see how drastic we can make it. Yeah, see now it's kind of just doing a little bit of jittering here. It's not really too much. So that's a little bit too low. Let's put this at 0.05. I like that. That looks good. So this time number 2 is the most polarized. What about in this one? So the thing is I don't want this 0 one, the 0, to generate data. I don't want to generate so I'm going to give a special key parameter to this generate data function so I'm going to give a special key parameter which will be optional. Solvent by default is false. So if you override the solvent property, right? So we'll say if solvent so if not solvent, then we're going to go ahead and create a buffer factor based on the X. Right? Else, so if not solvent, we're going to create a buffer factor. And then we're going to append the X, this. the buffer factor for the X value. If there's not a solvent, we're going to xdata.append just the compound index 0, and then no matter what, we're going to append the Y. Perfect. So now we're not even going to waste time and do this randomization for the solvent creation. So then what I'll do here is in the solvent, generate data here. All right, we're generating data on the compound. If key does not equal to solvent, then we're going to do this, else it does equate to solvent. So we're going to generate this again, but we're going to put solvent equal to true. And so now if we generate this, our solvent data should have no randomization associated with it. Which it doesn't look like it has anything going. It kind of does, maybe. Let's see. Let's say we generate the data here, and let's print x dict data here. Okay, so now we get the x dict data here. Now we want to look and find out, yes, we have our solvent has 0 for all of its x values. And then if we print the y dict data here as well, and run that, right, we get all of the x data here, but the solvent on the y data so let's just print the y data dict actually then. Oh shoot. So now the y data, the solvent, should just go up by linear. Nice. Up to 0.199. Awesome. So now the solvent isn't being applied to any random generation. It's just kind of going up on its own, just visually here. That's kind of like a progress of the total there. So now that solves that. See you, Orion. Thanks for coming in, man. Yeah, no worries. Thanks for following along. I'll see you in the next one. Thanks for joining me. You're great. You're real awesome, dude. This reminds me of a horse racing program I made, but the horses would start at a random but constant speed. Oh, that's a fun idea too. Oh, what if we did this? That'd be fun. Eduardo, what if we did this? I think it would be fun if somehow you could generate like channel points through, like, if you wrote a program that could track your YouTube watch hours on a certain creator, like they do for channel points on Twitch. So you could track your channel points on a certain creator, and then that creator could create certain events or games to basically do something with those channel points. And like you could have like a horse racing game where players can bet on a horse and it goes in a random, and then I think that'd be fun. That sounds cool. A little gambling game. What's your Myers-Briggs personality if you took it? Oh, I remember that from back in the day when that was kind of more popular. What are the different types that you can be? Arc. I'm gambling on compound 2 to finish first. Okay. All right, here we go. Place your bets in chat right now. Which compound 1, 2, 3, 4, or 5 is going to is gonna win the next race? Which one's gonna win? Place your bets, boys. Place your bets in chat. Let's see it right now. Which compound's gonna win? It's random, so we can. Right, we're generating a random retention factor. Mahan's got number 3. Tim says number 2. Eduardo says 5. Jared says 3. Okay, we got a couple for 3s. 1 for 5, 1 for 2. Okay, let's go here. Let's ready. 3, 2, 1, boom. All right, here we go. We're off the races. 1 is looking pretty strong. 1 is looking pretty strong here. 1 is looking like it might be the winner here. The only thing, I think 1 is going to take the cake here. If you said 1, oh, nobody got it there. Everybody lost. The house wins. Would have smoked y'all. So the thing that you can do that's pretty... Edward says 1 right after. That'd be fun, like, if you could, like... That'd be fun if you could insert some sort of randomness element to, like, the speed, like, at certain points. Like, it would just roll, like, if it would just keep rolling, like, the dice. And if you hit, like, a certain dice, you would get a speed adjustment. And then you would go down, like, or up a speed maybe, like, depending on where your dice hit. So if you got, like, a speed hit off of the random dice, your velocity could change, like you got your second wind or something. Or then you could throw, like, the users could, you could throw power-ups to it, to where you could throw it like a speed ball or something, and it'll speed up or whatnot. You could give it like in Hunger Games when they send like food or whatever in, you could send in stuff to your horse to make it go faster. Send in horse steroids. That's so funny. That'd be funny. Why do you do true if key is equal to quote solvent, else false? Where? Hold on. So you want to say in where? She said, why didn't you do true? Oh, well, by default, it's set to false. It's automatically set to false by default, so that's why. Solvent's kind of like the edge case, so to generate unique data for a solvent, where every X value remains, there's no randomization applied to it. All right, cool. So that's what we were able to come up with tonight here in these 2 hours of coding. We were able to accurately apply a randomization buffer to the individual x-axis points for these. Yes, so they will climb up based upon their retention factor compared to the solvent's rate, but rather than having just singular points linearly go up on an x-axis point, like kind of like just a parallel line or a right, whatever, we are now applying a little bit of randomization to each point as it scales upward across that retention factor, a little bit of wiggle to kind of mimic like a liquid like be flowing up, like, through the medium. So Distracted Funny, you like this project? This is a pretty cool one. This is probably one of my coolest ones so far because it really actually, it takes some cool STEM concepts that you do, as a freshman, sophomore in general chemistry, and visually applies them to code here. Now, what we could do is we could even mark like a game element to it. I think it would be fun to make it a game. And what I mean by that is the whole point of the general chem lab that you do this is you can identify unknown compounds in a solution by doing chromatography, or by doing, different types of chromatography or spectroscopy, right? If you want to identify what type of compound it is based on its refraction in light and its prism, you can do like spectroscopy and look at that. But with chromatography, you separate the compounds out by their physical using a solvent across a polarity medium, and that's how you're able to either detect impurities or detect unknown, like whatever, via control. So what we could do is we could give the user 5 chromatography instances and then 1 unknown as the 6th option, which is basically we'll basically copy the array of one of the other control values and then just slightly skew the numbers by a buffer itself so that you can then match basically, okay, let's say that 1 and 4 looked pretty similar. Well, then you could probably assume that 1 and 4 were the same compound in this lab, and that's how you're able to identify, oh, the unknown compound is X, because you knew that compound 1 was X, and if compound 1 and 4 had the same trail or the same kind of retention factor at the end of this simulation, right, when it reaches the top, that calculated retention factor, which we're just pre-calculating to visually do ahead of time, and that's how you would identify the unknown. So yeah, it's pretty cool. No, I'm not going to do Leet code tonight, Mon. We're doing this is enough math for me here. we're taking our wins as we. So now what I want to do is I want to so that looks really good. I want to, if I run, do I have any print statements anywhere? I do. Here, let's get rid of that. And we're printing out data. Here. Okay. How did you come up with this project idea? I literally was just sitting here editing one of my Python crash course videos, and I've been thinking for a couple of days to about a week now of like, I really want to display my chemistry knowledge to you guys and to employers, on make a resume and show a project that says, okay, I can mimic and model chemical experiments, laboratory experiments in code, and I can show those with visual data and visual representation and randomization. So I was like, okay, now how can I do that but not choose a subject in chemistry that is so broad or difficult or has a lot of different edge cases that would be pretty difficult to get started with and maybe like kill my spirits right off the jump. So I was like, what could I do? I was thinking maybe do like a chemical equation balancer, maybe doing a redox reaction redox reaction thing, or do but then I started to think, well, like those just seem a little bit too, they're not complex topics, they're very basic chemistry things, but it would require me to have a lot of different setup, and I wanted to maybe create a quicker project that had a little bit more impact and more of a visual element to it. And so I was thinking, okay, what were some of my beginner labs? And this is like the second lab you do in general chemistry, is identifying the unknown compound, doing thin layer chromatography or paper chromatography. And it's like, that's a great idea. So that's what we should do now. And then maybe next time what we can do is use some sort of, you know, modeling or something to, detect and output spectroscopy or something. I'm not sure how we could do it, but I'd have to look into it. And I just got, that's literally it. It's like, just what kind of lab did I do in Gen Chem that, would be easy to translate? And I was like, I started thinking about chromatography. I started thinking about a database. Okay, what if we had already predetermined RF values? Well, I looked those up. Those are not really predetermined because there's too many variables involved. So they're just calculated live during the experiment. There isn't like a centralized database for them. So I was like, okay, well, then let's just model what it would look like, by the user putting in stuff. And then now we're here. This is literally day 2 of the project. We started the project yesterday, and we're making some good progress here. Like, making some good progress here. So my next goal is I want to clean up the chart a little bit. I want to get my, axes labeling appropriately. I want to get my, distance going appropriately. Because it's not in centimeters. There's nothing actually like showing, like proving it's in centimeters. Like it's just a unit of 25 as it grows based on some factor. So I don't actually have a scale in this, so I got to think about that. But yeah. Um, but yeah, my goal is what we're gonna do next. So let's go ahead and let's get this merged in. So this is good. Git status. Okay, git add. I want a point buffer random. Non-solvent x values. Oh shoot, what was my branch called? I just pushed it to GitHub, I can look it up. Can't remember my branch name. Point buffer random. Give me the git command to delete the branch point buffer random from local and remote. Git branch dash D. Git remote. And then we delete, we push the delete. Okay, so now we go here and refresh. We have no point buffer random. We're active on that, which is 5 commits ahead of main. Perfect. Non-solvent vowels get X rand buffer factor. I merged that into dev, and then I deleted. Perfect. Nice. Look at us. We're using Git, making branches, merging back into branches, pushing, pulling. Ah, let's go. All right, you guys. Thank you so much for joining me this evening. We coded on the project for 2 hours tonight. I really appreciate you guys joining me. I'm gonna try to get to bed a little bit earlier tonight. I've been staying up till 12:31. Getting 6 hours of sleep is just wrecking me in the mornings, but I get up and push through. I really appreciate you guys being here and joining me. Please join the Discord in the profile of my Twitch or in the description of this YouTube live stream. I have all of my study resources, PDFs, notes, course breakdowns, open source projects that we're all working on together, the Small Business Manager coordinating in there. I'm going to be opening up some GitHub issues as the project manager to open up some current projects that were issues that we're currently dealing with and wanting to fix, and features to add. For example, the next feature that we're going to add to the Small Business Manager as a community for the community version is having the database be auto generated on launch in terms of file creation, and then continuously used, so that when you push and pull from GitHub, you're not getting the database. It's remaining as is unless need be, and it'll basically be included in the git ignore. So you won't have to, you won't have to use the file path basically to assign the database when and then put when it's being fetched and pushed each time. So that'll just make it so that everybody, you don't have to do anything with the file path. It'll just do it automatically. So that's going to be our next thing that we're currently discussing in the Discord. But I appreciate you guys for joining me tonight. Leave a like if you enjoyed the stream tonight. Very chill vibes, just coding, getting the project done, working on a math-based chemistry project in programming, which is fun and cool. I was really excited to get into this with you guys and continue on. Thank you guys so much for being here. Once again, my name is Mike. I'll see you guys tomorrow. See you guys.